The Orion Nebula is one of the most studied regions of our sky. It sits amidst the constellation of Orion, between the stars, and is so large, close, and bright it can be seen with the naked eye. It is a vast cloud complex giving birth to and nurturing baby stars. Because it is relatively close, at 1,344 light-years away, it's one of the most important observation targets in the sky for understanding star formation. Although we've been staring at the nebula since it was first officially discovered in 1610, however, we've not unraveled all its secrets. Now, the most powerful space telescope ever built has given us a new gaze into the heart of the Orion Nebula. These new observations allow us to better understand how massive stars transform the gas and dust cloud in which they are born. Massive young stars emit large quantities of ultraviolet radiation directly into the native cloud that still surrounds them, and this changes the physical shape of the cloud as well as its chemical makeup. Star formation is a very gassy, dusty process. Baby stars are born from dense clumps in clouds of dust and gas that collapse under gravity and start to accumulate material from the cloud around them, forming a disk as the star spins. I already made a video upon how solar systems are formed. If you are interested, then you can go through the link given in the description. All that dust and gas blocks light from escaping out to show us what's inside. However, the longer wavelengths of infrared light, the range through which jwst views the universe, are able to penetrate dust, which gives us a view into regions impossible to see in shorter wavelengths, such as the visible spectrum. This is the image of the inner region of the Orion Nebula as seen by the James Webb Space Telescope's NIRCam instrument. In this composite image from several filters that represents emission from ionized gas, hydrocarbons, molecular gas, dust, and scattered starlight. Most prominent is the Orion bar, a wall of dense gas and dust that runs from the top left to the bottom right in this image, and that contains the bright star Theta II Orionis A. The scene is illuminated by a group of hot, young massive stars known as the trapezium cluster, which is located just off the top right of the image. The strong and harsh ultraviolet radiation of the trapezium cluster creates a hot, ionized environment in the upper right, and slowly erodes the Orion bar away. Molecules and dust can survive longer in the shielded environment offered by the dense bar, but the surge of stellar energy sculpts a region that displays an incredible richness of filaments, globules, young stars with disks and cavities. In this marked region, young star with disk inside its cocoon, planet forming disks of gas and dust around a young star. These disks are being dissipated or photoevaporated due to the strong radiation field of the nearby stars of the trapezium, creating a cocoon of dust and gas around them. Almost 180 of these externally illuminated photoevaporating disks around young stars have been discovered in the Orion Nebula, and jwst-10 is one of the largest known. The orbit of Neptune is shown for comparison. In this marked region, filaments, the entire image is rich in filaments of different sizes and shapes. The inset here shows thin, meandering filaments that are especially rich in hydrocarbon molecules and molecular hydrogen. In this marked region, Theta II Orionis A, the brightest star in this image is Theta II Orionis A, a star that is just bright enough to be seen with the naked eye from a dark location on Earth. Stellar light that is reflecting off dust grains causes the red glow in its immediate surroundings. In this marked region, young star inside globule, when dense clouds of gas and dust become gravitationally unstable, they collapse into stellar embryos that gradually grow more massive until they can start nuclear fusion in their core and they start to shine. This young star is still embedded in its natal cloud. Comparison of image of the Orion Nebula, captured by jwst versus Hubble Space Telescope. The inner region of the Orion Nebula as seen by both the Hubble Space Telescope and the James Webb Space Telescope. The HST image is dominated by emission from hot ionized gas, highlighting the side of the Orion bar which is facing the trapezium cluster, off the top right of the image. The jwst image also shows the cooler molecular material that is slightly further away from the trapezium cluster, Compare the location of the Orion bar relative to the bright star Theta 2 Orionis A for example. Webb's sensitive infrared vision can furthermore peer through thick dust layers and see fainter stars. This will allow scientists to study what is happening deep inside the nebula. Comparison of image of the Orion Nebula, jwst versus the Spitzer Space Telescope. The inner region of the Orion Nebula as seen by both the Spitzer Space Telescope and the James Webb Space Telescope. Both images were recorded with a filter that is particularly sensitive to the emission from hydrocarbon dust that glows throughout the entire image. This comparison strikingly illustrates how incredibly sharp Webb's images are in comparison to its infrared precursor, the Spitzer Space Telescope. This is immediately clear from the intricate filaments, but Webb's sharp eyes also allow us to better distinguish stars from globules and protoplanetary disks. Here is a bonus image for you guys. Northern region of M42 observed with detector A of NIRCam during observation of the Orion bar. Can you find the frog in this image? I hope you found this video interesting. Consider subscribing Explore for more similar contents like this. You might be interested in these videos. I highly recommend you to watch these videos.